Hello, guys. Welcome back to my channel and welcome to chapter 8 of the Cross Origin Resource Sharing course. And in this chapter, I want to keep it as a demo session, practical, and we are going to demo from where we left off. In the previous chapter, we were discussing the request types. We talked about simple requests, pre-flighted requests, and credentialed requests that apply in the course specification. So in this particular chapter, I want to demo simple and pre-flighted requests. And if you recall, I mentioned that simple and pre-flighted requests are just two sides of the same coin. So basically, there are some criteria that qualify a request as a simple request, in which case they don't have so much risk, like GET requests. And if the request starts becoming more complicated and more custom, then it crosses from simple to non-simple request, in which case the browser has to do what they call a pre-flight request to first understand what is allowed, the access control policies on the server. So we're just going to demo those. We're going to move from simple all the way to the more complex requests. And we're going to be seeing what settings on the server affect the request type and what settings on the client affect the request type and the settings on the server that affect how the browser will behave. So on my screen, I have my IntelliJ with the Spring Boot application. Basically, it's still very simple. I've even removed the cross origin configuration, which was given by the cross origin annotation. And I've even removed other extra endpoints. I only have one endpoint here, slash API slash CORS. It returns CORS success. So when the server is able to return this response, then the browser will know that the request was successful. And depending on the core setup on the browser, it can allow this response. Consider this like a user data, which we are seeking to protect with the course configurations. So the moment the script is able to display this text, then we know that everything went well. So let me even make it a little more custom for this. Let me change this to chapter 8. Okay, so if we look at the client side, so I have my browser on the left and the IDE VS Code on the right. So I just wanted to put them side by side so that because every time we were making changes in the React application, it would be automatically compiled and updated. So the hot reload feature is going to be easier to follow if we have the two side by side, so that we can see changes in real time instead of scrolling left and right to be able to see the effects of our changes. So let me just walk through the React application. Actually, it's already running, and just to be clear, let me start. Let me make sure we start from an empty page. I've stopped the React application. So over here, you can see that it's still very simple. I have one div element here, which is rendering the default React page created by Create React App, and I have added here a variable to display, and this variable comes from the state variable I set here, and it's initialized to empty. And basically, the third component I have here, the third element I have here is a React hook, an effect that runs immediately when the application starts. And what it does is just to send a simple GET request without any headers to our backend API, and we expect this text to be received when the response comes. We extract it, and then we just log it. We don't even need to log, because now we are going to be we set it in the state variable, and when we see it displayed on the page is when we know the request was successful. So let's first start our React application. PM start. Okay, so it's going to open. Yeah, there we go. So I want to start from a zero configuration on the server, and then make our way upwards. So let me just open the dev tools here. Console tab will be very important. Okay, failed. Every time we make changes here, we'll first look on the page here to see if this variable has a value, the value that is sent from the server displayed here. And if it doesn't, we'll know there's a problem. And then we'll be looking at the network tab and see how the request went, whether it was successful or not, whether there was a pre-flight or just a simple request. And then we'll look at the console in case we think there's an error, like in this case. So what has happened here is the error is simply because we haven't started the backend application. So let's get that fixed. I'll come here, I'll start the Spring Boot application. So it's loading. So actually, one thing is that we're going to be alternating between server and client, and it's very good to have an insight on what's happening on the server so that we can connect it to what's happening on the client, and it will give us a more holistic view of things. So I the server is really very plain. The logs are very plain. I just want to enhance the logs a bit. I want to set it to debug so that because I mean, if we send a request now, the request it has failed. Okay, there's nothing displayed. But if we go to the server, there's no logs. Everything is clean, proper. So let's fix that by improving the logging. So in my application.yaml, I'm going to add a log level for the root. I'm going to add debug so that the logs will be a bit more noisy, but also more informative. Let me restart the server. So you can see the logs are more noisy, but I mean, it will help us troubleshoot things better. So, okay, now let me refresh the page and we go back to the errors. So the first thing to notice, as I said, is that our text from the server is not displayed. So the question is, was it returned? It doesn't seem so because the request ended in red. Let's open that request. Actually, it has status 200, but there are no response headers. There are no access control allow headers in the request. There is really nothing unique. It's just the origin is our front end origin. The host is the backend. So mode is CORS. So let's open the console to see what went wrong. So basically, what has happened, like we said, we're starting from the default mode with zero configuration. So the browser is saying that there is no access control or origin header. So how do we fix that? Let's now set up the Spring Boot application for CORS configuration. And as we saw before, we just need to add an access control. No, we just need to add a cross origin annotation here. And that alone with Spring Boot already sets up a default CORS configuration. And we discussed that in the default mode, everything is allowed. All origins are allowed. All headers are allowed. All request methods are allowed. So let's restart that and just see the effect on our blocked request. So now the server does allow, but browser the browser did not send any pre-flight. It's still a simple request because it's a GET request. There are no headers, nothing fancy. So let's see what changes. So when we refresh that, now all of a sudden we see success. This is the sign of our success. And the request is no longer red. Everything is still the same apart from the access controller origin. It's now present and the console is empty. So there's no error. So now we fix the problem by enabling CORS on the backend. Now the allowed origins are sent. That is our first test case. So from here, that's actually our second test case. So the third test case will be we've started from a very lax setup on the server. Because I had mentioned in previous chapters that this annotation creates a very free and open configuration. So everything is allowed. So let's fix that by trying to be more restrictive. Allowed origins. So origins. So I want to be specific about the origins I want to allow on my server. And so yes, so basically, I'm going to set this to an array of yeah. Let's set our real origin of the React application on port 3000. So when we start this, there's only one thing that is going to change. Nothing is going to change because remember, we're still allowing the origin. We're not blocking it. So just notice one thing here. Besides the success, the access control allow origin header, which was returned that solves the previous error, is actually a wildcard value. And that was the default setting. But now we've updated it to something more specific. And I just want you to notice that in this test case so that we clear that up. So, yeah, success. So now the access control allow origin header has changed from wildcard to a specific value, which also has some impact, whether you set wildcard or this in some scenarios, which we'll see in the near future. So the next thing I want to do is to change this origin. So if we change to say, I think 4200 is the default port for Angular. For React is 3000. So if we say we're allowing a different application on the React app, so now we expect a mismatch between the allowed origin and the actual origin that we're sending. So let's see how Spring Boot handles that. Right here, the server started. Let's clear this. Let's clear that. So to be clear, we expect this to fail, right? Reason being, there will be a mismatch. So let's just test that hypothesis. Yeah, so the request has failed. There's nothing displayed here. There's a red here. If we open that error, we see forbidden from the server. And what is in the request headers? Nothing new. And in the response headers, what has happened is that there are now no access control headers. The server short-circuited the request on the way after detecting a mismatch between the allowed origin and the requested origin, and it sent a forbidden error. So if we go to the server, we are going to see that what really happened for the server to throw this. So if we come here and we trace the request, you'll see that there is a file called default CORS processor, which detected that the origin is not allowed, and then it sent a forbidden error message. So one thing I want to mention about this is that Spring Boot is different from some other frameworks because other frameworks, and also on the advice of the core specification, is what they implement is that the server should not reject any request, but rather serve the request but with the appropriate headers. Then it's the browser to compare the requested headers versus the response headers and decide what is the failure reason. But in this case, the Spring Boot just failed with permission denied error. And as usual, we can check the console for the exact error message. So the error message hasn't changed from the other first error message we saw. So it's like there's no access control allow origin. The browser was looking for an access control allow origin in the response, but it didn't find. It received the forbidden. So it can't tell us exactly what went wrong. So the reason the request has failed is because the allowed origin and the requested origin don't match. And that is supposed to be clear here so that we are able to troubleshoot. But anyway, that's a nuance of Spring Boot application. I haven't checked with other frameworks. I've just read about the specification and how it's expected to work. But I think overall course specification is a bit flexible in this area as long as ultimately the script in question does not have access to the user data, and we've succeeded at that. So let me clear this, and we go to another test case where basically I want to deal with we're now going to cross over from simple request into the other arena of pre-flighted requests. And one of the determining factors we mentioned is the headers. So if you remember this diagram, we're talking about safe and unsafe headers. So there are access control headers that are considered safe. For example, these are they are called CORS self-listed headers. So if these headers are in the request, then what it means is that the browser will not see any threat in them. Actually, as a matter of fact, the browser sets these headers on its own. If we repeat that request and we look at the headers that was sent in the request, headers like accept encoding, cache control connection, they were not set explicitly. As you can see in the React code, our headers object is empty. And basically, the browser set these headers automatically. And to be clear, let's just experiment with one of the safe request headers, the content type. So content type was not sent in the request, was it? Yeah, it wasn't sent. So we can experiment with it. What happens if we add a content type header here? So content type and so again recall that we had added an asterisk or a star on the content type header because not all content types assigned to the header itself is considered safe, but to some extent. And the other 50% is determined by the content type that is actually put there. So these are the safe content types. That means since we're dealing with a plain text, we can use the text plain content type. And following the TDD approach, I think we can first hypothesize on what we expect. We expect a request to be sent and a response to be sent successfully without any pre-flight. This is still a simple request. Remember, we're transitioning from simple to pre-flight, but this is still a simple request. So just remember we had disallowed the origin. So maybe let me set it back to the relaxed policy so that everything is allowed and we'll be changing according to our needs. So the Spring Boot app is starting, and if we come back here, we've set our header to content type. If we refresh that, the request will be sent. So now we have success again because we relaxed the policy on the server. And if we open the request, we'll see that now the content type header is there. And indeed, this was still a simple request. The response came back, everything good. So this is still simple because the content type is safe and the value of the content type header is also safe. So we're going to try another thing. So now, what if we add a custom header here that is not in this list? Let's just try that out. Add a custom header here. It's called, let's call it X custom header v1. So if we add that header, now the request is no longer simple. And we know that what a request which is not simple will be pre-flighted. So we've cleared everything. I'm going to save this so that we see the request. So now instead of one request, we now have two requests. We have a pre-flight request and we have an actual request. So let's open the pre-flight request. What has happened in the pre-flight request? An extra, it's an options request as we saw before. We have seen an extra header here, access control request headers. So the browser is sending the details of the request to the server beforehand. It has also sent access control request method because we're using a get method. Remember we said that one of the other factors affecting simple or Preflighted request is the request method. But basically, this is either way a GET request would be allowed. So either way, the browser sends them the preflight, and the response is like this. So access control allow header, the server responds with that header. But remember, the server doesn't even know that header. So how come the server is responding with this header? Uh, Basically, we've looked at the preflight. I'm going to explain why the server responded positively. So the request went through. The custom header was added in the request, the actual request, and the response came back. So why did the server accept? Because of the same reason I mentioned earlier. The cross-origin annotation configures Spring Boot for cross-origin resource sharing, but it configures it in a very lax mode. Everything is allowed. So whatever is requested for by the script or by the browser is going to be allowed. So how can we make this more strict? So I'm going to make this particular configuration more restrictive by saying allowed headers. Let me add, should I add this exact header or I add something else? So now we've seen that a pre-flight request is sent. We've now crossed the domain of simple request into that of pre-flight requests. First by adding a custom header. And the custom header is allowed because Spring Boot is lax in the default mode. So let me, if I add this header in the request, it's a list of headers. The response will still be the same, so there's not much value. But let me change this to V1, V2, and and I am allowing V1, setting V2 here, so they won't match. Let me restart the server. So with these allowed headers, we are controlling which particular headers are allowed to be set from the request. We're no longer allowing everything, just like we did with the origin earlier. So the server started successfully. Let me come back here and I save this so that the request can be triggered. So when I save that, the request will be triggered. So now you can see the pre-flight request has failed. Let's open. Wait, why do we have that response? I think that is a cached value and I don't want to see it there. Let me refresh the page again. Okay, so now we've got the actual request. So we didn't expect the value to be set because the request failed. So let's look at the pre-flight request. Again, it's forbidden. It's forbidden, and again, this is not a very good thing with Spring because then we won't know what is causing the error to fail. The request to fail. The error message is going to be different, like we saw with the origin request. So again, request headers as X custom header v2. The server has not sent any response headers, and basically the browser it has forbidden the request as if it's an actual request, yet it's an options request. Options request should have only a value of success HTTP code, like in the range of 200. And that is what the specification says. That's what the fetch spec says about how options requests should be handled. But Spring Boot is handling it this way, which makes me really uncomfortable. But in a future video, we're going to really dive into how Spring Boot implements CORS and understand what is happening. Maybe we'll understand the reasoning. But for now, we deal with what it has for us. So custom header v2 was sent and the server basically rejected the request. Let's look at the actual request. Or still the options request. Oh, of course, it didn't send the actual request. All right, it didn't send the actual request. So when you look at the console, the error is basically the same: no access control or origin header, which is not very informative. It's not accurate. to describe the exact error we're facing. So let's say I add, let me just play with it a bit. Let me add the this header in the list of allowed headers, okay, so that it is, yeah, it's now in the list of allowed headers. We are going to expect success. We expect course success. We expect to print it here. Okay, so server has started. Let's refresh the request. It should be successful. Yeah, it's success. So pre-flight request asked for X custom header v2, and here request headers X custom header v2. The response header is allow. Right, everything nice, fancy, good. Response is success. Yeah, not very interesting, but good. So let's add the custom, let's just for the record, let's add our custom header v1. So if we refresh, should be successful. Yeah, pre-flight request. So the pre-flight request has added two custom headers here. X custom header 1, v1, X custom header v2. And the server has responded with both of them. So the server only responds with what has been requested. It doesn't expose any other headers that are allowed. And this is good. So what happens, let me add a third header here. Just copy this. X custom header v3. So of course we know this one is not allowed. So we just want to see it in action. All right. So this is something I noticed at the start. The pre-flight request was returning forbidden, and we would see it here. But now the pre-flight request is returning success. Again, I don't understand. It seems inconsistent. So initially, we were requesting a header that is not allowed, and the server returned with forbidden. But now we've added a third header. Only two of the headers are allowed, and it has returned success for pre-flight as the expected behavior. So this is the behavior I was describing. According to the course specification, options header should always return success. Then it's based on the headers that it sets in the response that the browser will know whether a request should be allowed or not. So, for example, here the browser requested for three custom headers: X custom header 1, X custom header 2, X custom header v3. And the server responded with only two of those: X custom header v1, X custom header v2. But the request was successful. So just to tell you the advantage of this, of course, the actual request was blocked, but let's go to the console tab and see what happened. So the error has changed from origin header missing to request header field X custom header v3 is not allowed by access control allowed headers in pre-flight response. Now that's a very specific error and it can help us to troubleshoot the issue better. So again, I still don't understand the inconsistency. When I apply two headers and one of them doesn't match, it forbade the options request. When I added a third one, two are allowed, it didn't. I don't understand what's happening, but again, like I said, we're learning and I'll explore this in a future video when I dig into how Spring Boot really works. So I just wanted us to see that and we're done. Let me just refresh to make sure the, the apparent success is not, okay. Um, Great. So now I'm going to look at another test case. I'm going to look at another test case. So the very last one we've seen is that an options request is sent and the results are more desirable. At least we get an error that is clear. So let's erase that error. We clear this. So let's say a user received the previous. Actually, let me first comment out this, and I only have one custom header that is allowed and one that is not allowed. Let's see if the pre-flight request will be accepted. Yeah, it is. Okay, and the error message is accurate. This is good. So let's say that a developer saw the course error that was shown earlier, where the browser complained that there is no access control allow origin header, and the developer decides to choose the option given by the browser to disable CORS. Basically, they don't know how to fix it, but the browser error said, if you're okay with opaque requests, just disable CORS and you'll be good. So the developer jumps to the fetch call and adds mod no CORS. Remember, we saw this earlier. Okay, so I just want to first make sure we see the header in the actual request. Okay, request wasn't sent, but there is the fetch mode was coarse, but now we're going to see how it changes with this config with that mode we've set. So let me refresh. Let me save that. Okay, so now there's no pre-flight request. Remember, a pre-flight request is triggered when the browser detects that this is a cross-origin request one, and it's not a simple cross-origin request. Second condition. So based on that, it will trigger a request. But we have a request which is not a simple cross-origin request, as we saw earlier, where we were sending pre-flight requests. But now we've disabled CORS. So since we've disabled CORS, the browser says, okay, no problem. So CORS is inactive. And what's the result of that? The result is that in the request headers, there is no more origin header set. All right. So without the origin header, the server will not even respond in a coarse manner. Okay, it will just respond to it like a normal request, like a request that's coming from maybe an HTTP client like Postman or any of them. So no origin header, no allow origin response headers in the response. So, and then also here you can see the fetch mode is no coarse. And basically, when you're troubleshooting these issues for someone and you typically ask them, share with me your headers, and then you can be able to advise them. So I wanted us to see the effect of changing to no course. But most importantly, if you haven't already noticed, none of these headers are added in the request. Okay, so look at the request headers. The safe header remained in the request. Okay, the safe header content type remained in the request, but none of these other custom headers, which should be heavily governed by CORS, was added. Because you disabled CORS, the browser kicked its default security mechanism and refused to send any custom headers. Okay, so it's like, okay, you've not presented your invite to the party. All right, you can hang around, but you're not going to get in. Okay, feel free to hang around, but if you want to get in, show some invite. So, no, we've disabled calls, so there's no pre-flight request, and there's no origin header in the request. The server doesn't know that this is cross-origin request. It sends the response as normal, but the browser knows what to do. It refuses to send your custom headers. So this is the effect I wanted us to see from disabling the cross-origin resource sharing on the browser. So this video is already getting a little long, but I'm going to continue in the next video, the same chapter, and we're going to have a look at other ways of triggering pre-flight requests. And then at the end, we're going to explore the cache function, right? So, do we want to cover the cache function now? Yeah, options with cache. We're going to cover that because I talked about the access control max edge header and I didn't say much about it. So we're going to make sure we cover that in the next video, which is a part 2 of this chapter. So thanks very much again for following along, and catch you in the next video. Thank you. Bye.